Hello there! In this video, I'll be covering the second passage of the science exam, and the first question in the second passage is question 7. So let us start here. Question 7 is asking us to interpolate the CNF value for a reaction time of 2 days for the first experiment. Experiment 1 corresponds to trials 1, 2, and 3. In trial 1, the reaction time was 10 minutes. And this led to a CNF value of 6 milligrams per kilogram. Trial 2 had a reaction time of 3 days, and this corresponds to a CNF value of 39 milligrams per kilogram. Because the reaction time of 2 days is in between 10 minutes and 3 days, we can conclude that the CNF value is most likely going to fall in between the two values of the CNF that correspond to these two reaction times. So in other words, the CNF value is most likely going to be in between 6 milligrams per kilogram and 39 milligrams per kilogram, leading us to conclude that answer choice B is the correct answer for this question. Alright, so moving on. Question 8 is asking us which combination of reaction time and filtration method results in the lowest value for the CNF. Well, just looking at the table, we can see that trials 1, 2, 3 correspond to the standard method of filtration. Trials 4, 5, and 6 correspond to the vacuum filtration method, and the corresponding CNF values are 6 milligrams per kilogram, 39 milligrams per kilogram, 42, 58, 69, and 73. Well, the lowest value for the CNF occurs in trial 1, which corresponds to the standard method of vacuum filtration, and also corresponds to the reaction time of 10 minutes. So the correct answer for this question is F. Alright, question 9 is asking us whether the net force exerted on the mixture in the funnel was likely greater in trial 3 or in trial 6. Recall that in trial 3, the standard method of filtration was used, and in trial 6, the vacuum filtration method was used. So there are really two ways to do this question. The first way is by looking at the CNF values. The CNF values for the standard method of filtration are 6, 39, and 42, and the CNF values for the vacuum method of filtration are 58, 69, and 73. As we can see, it appears that the values for the CNF are greater for the vacuum filtration method, which would lead us to assume that the net force is greater in the vacuum filtration experiment, which leads us to conclude that the correct answer is C, because there is a new vacuum pump that creates a new force. And this also complements the second way to do this problem, which is to draw a free body diagram. So trial 3 corresponds to the standard method of vacuum filtration. If we let the mixture be the free body objects, there is a force that points directly down for the standard method of filtration, and for the vacuum method of filtration, there's also the force of gravity, but there's also the force of the vacuum pump. So this also leads us to conclude that answer choice C is correct, that the net force is in fact greater for the vacuum filtration experiments because there's now a vacuum pump. Alright, so let's move on to question 10. Question 10 is asking us to recap the chronological sequence of events for each of the experiments. And there's a little passage that follows the experiment 1 that documents the steps that were followed in experiment 1. And let me quickly recap those steps. Step 1 is mixing the ions. Step 2 is stirring the mixture. Step 3 is recovery of nickel ions via filtration. And 4 is determining the CNF value. So the only sequence of chronological steps the only sequence that correctly describes these steps in order is answer choice G. All right, so let us move on to question 11. Question 11 is asking us whether the data support the notion that a greater CNF value will result for a reaction time of 3 days than for a reaction time of 10 minutes under the technique of vacuum filtration. Well, trial 4 corresponds to vacuum filtration for 10 minutes. So 10 minutes leads us to a CNF value of 58 milligrams per kilogram. In trial 5, the reaction time was 3 days, and this leads us to a value of the CNF of 69 milligrams per kilogram. And if we look at this data, the CNF value is in fact higher for 3 days than for 10 minutes. So yes, the data does support this notion, and that's because the CNF value for trial 5 is in fact greater than the CNF value for trial 4. All right, so that leads us to conclude that the correct answer is D. With that being said, let us move on to question 12. Question 12. In how many of the 6 trials was nickel hydroxide monohydrate recovered by standard filtration after being allowed to react for at least 3 days? Well, there are 2 key points in this question. The question is asking us for the trials that were conducted under standard filtration. So that corresponds to trials 1, 2, and 3. And it's asking us how many of those standard filtration trials were conducted for at least being the key word, 3 days. So only trials 2 and 3 count. So the correct answer is going to be answer choice G. All right, let us move on to the very final question in this passage, which is question 13. Question 13 is asking us if 6 hydroxide ions are consumed, how many formula units of nickel hydroxide monohydrate are going to be produced? And we can see that the balanced chemical equation that is presented in the passage is 1 ion of nickel 2 reacts with 2 hydroxide ions and a water molecule to produce 1 formula unit of nickel hydroxide monohydrate. So we can see that in the reactants in the reactant side of this chemical equation, that 2 hydroxide ions are consumed to produce 1 formula unit of nickel hydroxide monohydrate. So if we multiply the reactant side of the equation by 3, it'll give us 6 hydroxide ions. So let's do that. Multiply this side by 3. But because we multiply the reactant side of the equation by 3, we also have to multiply the product side of the equation by 3. So this tells us that 6 hydroxide ions need to be reacted to produce 3 formula units of nickel hydroxide monohydrate. And that corresponds to answer choice A. With that being said, this concludes this video. Thank you.